Hello, welcome. All right, so I am going to look at this problem right here on the review as a little test review section. All right, so let's start with our domain. Remember, the domain is everything like how far to the right and how far to the left does this line go, all of the x values. All the x values, but and remember, x axis is right here. But the way I remember it is I say, okay, how far to the right does this line go, and how far to the left does this line go? All right, so if I'm looking this way, here's my x-axis. I'm looking here. It looks like this line goes like this. We've got a little arrow. I know that the arrow means it keeps going like this, even outside the graph. If I'm looking at this and I'm now drawing in, here's my x-axis, and oh, my x-axis has an arrow as well, so I know it keeps going as well. Okay, it looks like the further to the right, like the further up this line goes, it goes further and further to the right as well. And since there's an arrow there, I know that it's going to continue going to the right, and there's an arrow here, so I know it's going to continue going like that for forever. And the mathy way to write forever is to write an infinity sign. We talked about this in class a lot. Because I can't hold infinity, I'm going to put a soft bracket around that one. All right. Infinity is an idea. I can't hold it. Okay, now let's take a look at the other side. How far to the left does this line go? Once again, it's got this arrow. I know that the arrow means it keeps going and going and going and going and going till I can't even see it anymore. If I'm looking here at my x-axis, because there's an arrow right here as well, I can see it just keeps going and going and going, even off the graph. Okay, so as I'm taking a look at this here, it looks like the further up this line goes, it also goes further and further to the left. As it goes further up, it's going further to the left. Okay, and it looks like it's going left and left and left and left and left and left because of the arrow. I know it's going left forever. Now, the mathy way to say forever is once again an infinity. But these numbers aren't going off to infinity, they're negatives. -6, whatever, right? These numbers are going off to negative infinity. Okay, so I'm just going to put a negative sign right there. Once again, I can't hold infinity, it's an idea, so I'm going to put a soft bracket around it. All right, let's look at range. Range is all of my up and down values. How high up can this line go? How far down can it go? And it has to do with the y values. Here is our y-axis right here. All right, let me erase some of this really quick. All right, let's take a look. All right, so if here's my y-axis, right, this guy right here, okay, and it's got arrows, so I know it continues even off the page. I'm wondering, okay, how far up does this line go? It looks, as I draw, I've got an arrow right here, so I know it keeps going off the page. I've got an arrow on this side, so I know it keeps going off the page. Oh, it looks like it's going up and up and up and up and up for forever. Now, what's the mathy way to say forever? Once again, we're going to put an infinity sign there. Okay, well now here's where things get interesting. Because how far down does this line go? How far down? Whoop. Oh, it doesn't go down forever. It stops going down right here. Where does it stop going down on the y-axis? Looks like it stops going down about here at -9. Okay, so I'm going to put -9. Now, I can't hold infinity because infinity is an idea. I can hold 9, though. I can hold 9 things, like rocks or grains of sand. And so I'm going to put a square bracket around that one. Remember, if it's just a normal number, put a square bracket around it. Oops, that erased it. All right, there we go. Alrighty, that is our domain and range. Please join me for the next video.